Just a couple of minutes to go. We're nearly filled up. We're about 80 people. What I was going to do was we're going to change the format of things tonight slightly. For those of you who don't know me, I'm John Souter. I've recently taken over from Jonathan as the president. Thank you, Jonathan. I'm so loved. Okay. One of the things that Newcomen has always been known for is the after talk discussions. And what I would like to do tonight is to see if we can emulate that here. So whilst it's still very, very happy for you to submit your questions but via the chat line, if you wish to actually speak at the end, please use the raise hand function and I will get to you as quickly as I can do. It takes a minute or two to find people and turn them around, but we'll do that. The other thing is I thought I ought to say something very, very quickly about what we're planning to do this back end. Since the announcement last night, I've already had contact from two of the venues we meet at, Newcastle and Sheffield, asking what our plans were. Were we planning to meet again? To which I've replied yes, and they are very, very keen to have us back. So the current plan is that we're going to restart some sort of in-person meetings, probably in October, might make them in September. For those of you who are happy with the online stuff, we have 2 more meetings lined up online and a third, and I've got 3 trial meetings in Sheffield. So on the national programme, on the 16th of March, we've got Paul Bell speaking about greens, the architects, builders and engineers in Newcastle. I've heard that talk yesterday. It's absolutely fascinating and it's really good. We also have probably a first, well, for us, we're actually going to do a formal joint meeting with the Stevenson Locomotive Society on the 20th of April, when Michael Bailey will be speaking about Michael's and Peter work on Invicta. We're also going to run 3 trial meetings out of South Yorkshire. Now, we may have spare places on these. If we are, we'll circulate the link round. In these, we're going to have a small audience present, and we're going to do it as both an in-person and online talk. If it works, the idea being that we will then do all the talks going forward, or as many as we can do, as online. So on the 19th of April, Jonathan is going to be speaking about transfer of strip mill technology. 24th of May, we have a local GP and public health specialist speaking on the history of water. And on the 21st of June, we have something which is probably a very relevant paper. We've got a paper on the development of the RB211, which, given Pratt & Whitney's problems today and with fatigue, could be a very, very interesting discussion. With that, I'm going to hand over now to Kevin Murrell, who's got a fascinating talk on the Wolverhampton atomic computer. Kevin, the floor is yours.
Thank you, John. Thank you all for staying in this evening, I suppose is the obvious thing to do as well. I'm going to talk about the Harwell Dekatron computer. This has become a huge story, actually. And the more, as time goes on, we know more and more about the machine. So I'm going to limit a bit of my story really to its early days, its construction, why it was built in the first place, why it ended up in Wolverhampton, and then subsequently how it's actually been installed and restored at the National Museum of Computing. Now, the picture that you can see on the slide at the bottom, it's a fairly arty picture, but we have something with a bit more detail later on. So I need to take you back to the immediate post-World War II period. We had shared a lot of our knowledge and people across to the States, to the Manhattan Project, to the development of the atomic bomb. But we had an arrangement with Roosevelt and Churchill that between Roosevelt and Churchill that we would share all that technology afterwards. So when at the end of the war, people would come back to UK and to Europe with that knowledge. Sadly, Truman, by this stage, at the end of the war, Truman's in power in the US, actually here, and the Americans lost the agreement. They also put together a particular act to stop any of that information being shared. So England was fairly sort of cut adrift, but there was a determination. Ernest Bevin attended a meeting over in the States and got fairly short shrift from them, and came back and apparently banged the table in a cabinet meeting to say, we have to have this thing here with a bloody Union Jack flying on top of it. So in 47, it was finally announced that actually we would start our own atomic energy research. And in fact, it wasn't until May that the actual program was being discussed in Parliament. So the first job was to set up a research centre in the UK. So John Cockcroft was asked to be the director of the Atomic Energy Research Establishment. So John would rather have had the research centre over in Cambridge Academic, but the RAF, who had suitable bases, wouldn't give up anything in that far in the east of the country. But they would be happy to give up RAF Harwell, just south of Oxford. Harwell was suitable. It was relatively flat, had quite a lot of accommodation, for which they would need, and hangars and buildings to start building the research centres, building the laboratories, and so on. It didn't always go absolutely to plan. I quite like this picture. This is a ventilation chimney above one of the first reactors that they built at Harwell. Not for smoke, it blasted 5.5 tons of cold air up through the reactor and up through the chimney. Terrific, easy design and so on. When they first started to test it, they realized they'd built the biggest organ pipe in Europe. And you could hear this thing, this sonorous sort of boom, about 30 miles away. So it didn't always go to plan. There are lots of stories from those days. You can see the construction going on. The plant was locally known, but the contractor that did all the work was a company called Chivers. And so the plant was actually known as the Jam Factory by locals. But Harwell got going. John Cockcroft went and did the rounds of all of the wartime research establishments to bring people in. They built their first reactor at Harwell in 1946, went critical a year later. As an aside, this reactor should have been kept as a national monument. It was used for many, many years as the reference source for calibrating equipment, but sadly, it is all gone. One of the problems, though, was that a lot of the fundamental research on atomic energy wasn't shared by the US back with us. So things like decay times and just the physics of atomic energy was pretty well unknown in this country. So a lot of fundamental research had to take place. The only equipment or tools available to the hundreds of maths graduates Harwell employed were electromechanical calculators, the Facets and the Brunswickers, which we all recognize, and printed tables from the American Mathematics Project. And these are huge volumes of solutions of things like differential equations. They were quite expensive and very limited. An awful lot of the work was just hand calculations that went on and on for ages with all the usual problems. So a solution was really required. John Cockcroft was, in a sense, embarrassed about employing all of these bright young maths graduates, giving them pretty mundane and boring jobs. But a chance compensation between the theoretical physics group on one of the electronics groups, literally over the garden fence, thought, well, actually, we could probably make a machine to do this. Our three designers, Ted Cookie-Arborough, Dick Barnes, and Gurney Thomas, had actually been over to Cambridge to see the EDSAC machine running. They were fairly, Ted Cookie-Arborough, Dick Barnes had both come from Malvern and had been working in wartime research. They were pretty switched on chaps at the time. Dick Barnes particularly had developed a lot of the chain home, the calculator, the electromechanical calculator using the chain home system. So the first job they have to do is then actually to make a case to the head of Atomic Energy Research Establishment, John Cockcroft, and his head of theoretical physics, Klaus Fuchs. We'll come back to Mr. Fuchs shortly. The proposal typically went that our three engineers would turn up to John Cockcroft, present their plans. They would expect a really vigorous discussion to actually share all of this information. What actually happened on the day was that neither John Cockcroft or Klaus Fuchs seemed particularly interested. And eventually, John Cockcroft called the meeting to an end and said, yes, it sounds like a good idea. Why don't you just go on and get on and do it? Putting all the dates together afterwards, and at the time, it was that morning that Sir John Cockcroft had been told that Klaus Fuchs was a Russian spy. And Klaus Fuchs then was facing pretty well immediate imprisonment afterwards. So you can imagine that they weren't particularly interested in the design of this machine. This is one of the only photographs of the machine when it was at Harwell. It's almost like the machine's passport photo. I'm going to just move my window of all the people out slightly. Moment. Let's move that. I'll go back a page. It's an electromechanical computer. All of the logic, the program control, and so on, is relay based. So behind all of those semicircular covers you can see there are banks of relays. The store used Dekatron tubes. We'll come on to Dekatron tubes in a moment. But the design was completed in early 50 and was built at Harwell itself with just enough stores, just enough memory to actually use the machine. It was completed in 1951 and was put to use immediately. It was never designed to be a fast computer. That wasn't a particular requirement. What was a requirement is the production of tables. I mentioned earlier these tables from the WPA project in the States. These listings of solutions to equations. This machine was designed to do just that. So it would run very slowly. And in fact, a multiplication could take 18 seconds in the worst case. But it was incredibly reliable. So reliably, in fact, actually, it was run continuously. It got moved out of the research department at Harwell into the abandoned old aircraft control tower that RAF Harwell had left behind. So it could be left to run continuously. The machine was incredibly successful in a sense, actually. It worked from day one. They added the rest of the stores fairly quickly. And the maths department sat down to actually program the machine. The reliability partly was because the jobs for the computer were prepared on paper tape. There was a problem with the program that would normally cause a crash, for instance, these days. The computer would actually reset itself automatically and carry on for the next job for from the paper tape. So it was quite possible, and indeed it's done, that the actual machine would set up with data to run. And in one particular case, it was over Christmas and the New Year. And when they came back after a fortnight's break, the machine's still actually running. Now, there is a sort of slightly apocryphal story that Bart Fossey, who was one of the senior mathematicians at Harwell, sat down with the machine and attempted a race with the machine. Now, this is Jack Howlett telling the story. And Bart Fossey kept up for about half an hour, running at the same speed of the computer. Gives you an idea of how the computer is. But the computer, Bart actually apparently retired after half an hour exhausted, but the machine just ploughed on. So the machine was actually, I think, loved is almost too much of a word. They were very, very proud of this computer. It was doing a fantastic job and was used pretty well continuously. Now, Ted Cook-Yarborough, who's actually sort of admitted this was a slow computer, and the comment here, a slow computer can only justify its existence if it's capable of running at long periods unattended. And running 55% of the total time available was actually pretty spectacular when you compare it with, say, equivalent machines that might run for an hour or two before, let's say, a valve died and so on. Ted Cook-Yarborough was slightly cagey. There's a comment there in brackets saying omitting a 5-week pause to damage, due to damage. We'll see some pictures of Ted Cook-Yarborough, but it's only really in the last few years that Ted Cook-Yarborough actually admitted the machine was damaged because he leant against it and knocked one of the store units to the ground, breaking up the actual store unit. Everybody else on the team apparently was absolutely thankful that it wasn't them that had done it, but as long as it was the boss that had done it, it was okay. So it was used, that's the first year of running of the machine. Of course, by 1957, Harwell have actually moved on. They built one of the first transistorized computers. They were buying commercial machines like PTM 555 and a Ferranti Mercury. And of course, they had access to their colleagues down at AWRE who had things like an IBM Stretch and an Atlas. But it was decided not to dismantle the machine. And in particular, a chap called John Hammersley, who was working at Harwell at the time, put together a competition for further education colleges and universities that might put together a bid to take over this machine. I haven't got the quote with me here. John Hammersley was pretty sort of disappointed in the way mathematics was being taught at schools. One of his papers referred to the soft intellectual trash being taught to school children. But the competition was put together, organised by the Oxford Mathematical Institute. They received over 30 submissions from further education colleges, schools and universities, of which Harwell produced and Oxford Mathematical Institute produced a short list of 9. Now, the 9 contenders were then asked to actually visit Harwell to see the machine and put their case to John Cockcroft. Several of the teams actually arrived, complete with the Lord Mayor or the Mayor, with chains of office and councillors and so on. So this was quite an event over a few days. But I'm pleased to say that the winners were the Wolverhampton and Staffordshire College of Technology. Now, one of the lecturers at Wolverhampton was a chap called Cecil Ramsbottom. Cecil Ramsbottom was adamant to keep this information, keep this machine in the news, and keep promoting the college. And this has been so useful to us because the number of press articles and papers produced is really a result of Cecil Ramsbottom's work. That we're very proud of ourselves. They made the quote, they actually had received support to physically get the machine. So the plan was that the machine would be available for hire to industry and commerce in the Midlands. I suspect they had a fairly vague idea of what the computer would do. There was a comment again in one of the press articles, it can, for instance, work out wage calculations much more quickly than human beings. Sadly, that's absolutely not true. Any bookkeeper could run through a payroll much faster than our machine. And of course, the comparable commercial computers were simply unaffordable for colleges like Wolverhampton. That was in March 1957. They didn't receive any help from Harwell. Harwell sent them off with all of the manuals, spare parts, fault-finding guides, but really couldn't spare the time. So actually, Wolverhampton did really quite a good job. It took them 3 or 4 months and reassembled the machine and got the machine working again, which is pretty spectacular. And at that point, the machine gets renamed. It gets named called the Witch computer. It's a bit tortuous, but Wolverhampton instrument for teaching computing from Harwell. And again, there are more press coverage there that Cecil Ramsbottom put together. But it did enable the actual college to start that first undergraduate course in computer technology in '65. One of the things about having the machine back on display is, of course, we actually meet people that use the machine at Wolverhampton. I think we have a few people in the audience tonight. We also, as a visitor to the museum, 8 members of that undergraduate computer course the first year came to the museum to see it. They were all snapped up really by IBM. So these guys, when they were coming back to us, ladies and gentlemen, came back to us, were all about to retire from IBM. So I think it really gave them a very good start. As well as actually teaching at the college, it was used for night school classes and for local grammar schools to bring students in. And it was used quite extensively for that. And I think Suzanne in the audience, who might be here from later, actually is one of those students. It would be quite ironic if it was her picture. But again, these are more pictures of the machine at Wolverhampton. Wolverhampton, after its 10 years of use, organised what was called the Witches Anniversary Lunch, and actually brought the buyers back from Harwell to actually see the machine working. And I think that must have been really quite a special occasion, actually. The Harwell chaps had moved on to other things. Go back and see this working must have been quite fantastic. Wolverhampton had an ex-post office engineer, which at the time is extremely useful because ex-post office engineers that were used to using Strowger equipment know how to maintain relays and the contacts. So the machine was kept working all of this time. It's spectacular. Key picture, and in fact one of the most famous pictures of the machine, was this one that was published again in the Wolverhampton Express and Star. And this is a student at the time on the left, Peter Burton, and one of the masters from the college, Frank Hawley, on the right. Peter Burton was just waiting to go up to Cambridge to read maths, but had been using the computer while he was at school, and went in over the summer vacation before going up to Cambridge to effectively honour one of those promises to local industry. The local industry was Chubb, the lock maker. One of the problems apparently in designing locks is that designing the keys is that certain patterns are too weak, or two of the pins are actually end up too weak and are difficult to manufacture or won't last in practice. So the guys actually set about programming this. Now this picture's a tad contrived. Peter Burton sadly passed away last year. That it looks as if we're both looking to try and establish whether there are holes in the paper tape. But it's an absolutely wonderful picture. One of the things that come on to actually, if I look at the code of the computer. I'm going to go back one. One of the problems with paper tape, the machine used electromechanical paper tape readers. So these are pins that are going to push up through the tape. Now, Harwell, with its slightly grander budget, was able to use mylar for the tapes, so they would last. Wolverhampton couldn't afford mylar. So what they would tend to do is punch the same routine multiple times around the tape. Now, Frank and Peter here are holding an actual loop of tape. So what they would have done with that is programmed a routine. Let's say it's a routine which calculates square root. They would program that probably 20 or 30 times on the paper tape. Trail the paper tape around light fittings in the room. So while this program was running, and the Chubkey program took 10 days to run, they wouldn't actually wear through the paper tape. By the time 1973, Wolverhampton, by that stage, had acquired an ICL 1900 machine. So the Harwell machine, or which as it was known at that stage, had gone into semi-retirement. It's still being used occasionally. Cecil Ramsbottom, bless him, arranged a whole day for the retirement of the Which. And as another piece from the Express and Star, Which the computer earns part retirement. Apparently the IBM machine that they'd also got played a tune, and the ICL 1900 produced the artwork, which we'd love to have actually seen, the line printer. But the other thing that Cecil Ramsbottom did then is had the machine listed in the Guinness Book of Records in 1973 as the world's most durable computer. Now we'll come back to that particular story shortly. So 1973, the second retirement. And again, it was important. Nobody wanted the machine to be broken down or dismantled. It was actually transferred to Birmingham Science Museum. Now, I suspect some of the audience will recognize that, the old original Birmingham Science Museum, which was absolutely fantastic. I spent every Saturday there from, I grew up in Birmingham. I spent every Saturday there from my sort of 12-year-old to about 17 or so. It was an incredible, that's just the front of the actual Science Museum. It followed the line of the canal down there, and it was absolute treasure trove. So the machine was put on display, I think, and my mother guarantees this was me as a 12-year-old at Birmingham Science Museum, actually in front of one of the engines. So let's go back. The machine was put on display, and with the intention, and I think it was a chap called Mike Constable at Birmingham at the time, the intention was always to have the machine working at that point. And in fact, the museum wrote to Harwell to see if Harwell could actually sort of offer some advice or help get the machine working. I don't think it was ever worked there. If anyone remembers the Science Museum, it initially was upstairs behind this huge Magnox reactor, where the Fox and Geese machine was, and then later moved downstairs. Now, in 1997, of course, with the start of the closure of the Science Museum, it was then actually moved into storage again. A lot of the machines from the Science Museum from New Hall Street went into the museum's collection centre at Charlotte Street. Now, this was a picture that one of my colleagues took, and this is zoomed in quite a lot. He was actually at the collection centre looking at a completely different machine, but managed to take some pictures of what was in packing cases and storage boxes and so on. Didn't particularly recognise this machine, and it wasn't until, where are we? Talking about 10 years ago now, I was going through these pictures, looking for something else completely different. Found this picture and thought, hang on, I recognise that control panel. And you can just see the black control panel with the switch, with the white and red switches on it in the distance. I recognise that control. That's the Which computer. We then paid a visit to Birmingham Museum's super new collection centre, which is down near Vauxhall Railway Station. That's a fantastic facility. And we were faced with this obstacle course. If you look right in the back, the distance is the Harwell machine, or part of the Harwell machine. We had to move absolutely everything else out of the way. This is an Orion computer in front of it. We moved everything else out of the way and actually found pretty well all of the components of the machine. It had been disassembled from the Science Museum not terribly well. A lot of the racks had been cut apart, but everything seemed to be there. One of the wonderful things about museums is they don't tend to lose anything. They can never find it, but they certainly haven't lost it. So we spent a long time at the museum, found all the components as well. And it looked at that point as if there was a possibility that actually the machine could be put together back again and restored to working order. One of the issues, of course, is if you're going to start a restoration project like this, is have we found all or sufficient of the hardware? Do we have any access to the manuals, the diagrams, circuit diagrams and operation guides? Even at this point, are the original designers or users or programmers of the machine still around that might be able to help? And the biggest question, do we have everything we need to restore the machine? Do we have the people with the skills and the time, finance potentially, and space? Space is particularly important. And to what end are you going to restore the machine? What is the eventual plan to actually do with the machine? And should we attempt the project? Now, there's quite a lot of thought in this as well. And with the help of the Computer Conservation Society, and a huge amount of expertise in this, we decided, in fact, yes, it would be a worthy project. One of the things we did find on a subsequent visit to Birmingham is this box of spares. Now, this came from, we had to hire a forklift truck, strap one of our chaps to the front of the forklift truck, drive up and down these racks in the storage centre looking for anything likely. And we found this box. Now, this has spares for the machine. This is the top layer of the box. There are some test paper tapes to the top right-hand side, valves, but importantly, which we didn't realise, is when we lifted these front two boxes out, complete circuit diagrams and theory of operation of the machine was in the bottom of the box, which was just absolutely unbelievable. So there are everything from spare ribbons and software, tools to maintain the relays, the theory of operation, which Harwell had produced at the time, which is beautifully produced and incredibly detailed. And we would have had a huge problem without the guide. The other thing, courtesy of the British Computer Society and the Computer Conservation Society, we were actually put in touch with the designers of the machine. Now, the slightly frail-looking chap sitting down is Ted Cookie-Arbor, and this was at his home in Abingdon. And the chap standing up, looking over, looking slightly quizzical, is Dick Barnes, one of the designers. They had kept, both of them, kept scrapbooks of what had happened to the machine. And they kept all the paperwork from Wolverhampton and so on. So one of the first parts of this meeting, and I think there's a picture of me looking at my scrapbook, comparing with Dick Barnes. They were absolutely overjoyed that this machine had been acknowledged and was likely to be restored. And both Ted and Dick were extremely helpful. So that was in 2009. So by that stage, we decided, in fact, that we had a case to actually restore the machine. We made the proposal to the Computer Conservation Society initially, and then put our proposal to the Birmingham Museum's Collection Centre. Now, there's obviously a worry here as well. There's a tension between a museum curator that does his absolute best to preserve the machine and see that no harm or change comes to it, and a group of enthusiastic computer engineers who want to get the machine working again. But we persuaded that the Birmingham City Council eventually and the museum's collection centre that we would actually be able to do this. And the machine was actually transported to the machine 3rd of September in 2009. Some of the restoration project itself, the machine had suffered over the years, and although Wolverhampton had done their absolute best to keep the machine working, there was quite a lot of damage. Needed repairs, the usual problems of rubber-covered cables and so on. These cables on the left look like they've hit the wrong end of a hot soldering iron, I think, as far as I can understand. Mostly, the machine was just absolutely filthy. Some of the rubber-covered wiring needed to be changed. Now, generally, what's happened in the whole restoration process is the wiring itself would be left in place and the new wiring put in parallel. Nothing has been removed from the machine. So all of the original components are still there. The connections between the various racks had suffered because of solder joints and bad joints, broken wires, but actually it worked really quite well. A lot of the components, bear in mind the age of components, of resistors and components that were purchased in the late 40s, had changed values over the years. So that took quite a lot of investigation. Dekatron tubes themselves, the gas-filled tube, actually seem to have an incredible life. There's very little you can do with a Dekatron tube to damage it. So all the stores actually worked perfectly. We didn't know how to program it either. So there was quite a learning curve of us learning how to program the computer. I'm conscious I've got 10 minutes, yes. When the machine was restored to working order, we arranged a meeting again to bring the designers back into the museum and the users, working left to right here. We have Peter Burton from Wolverhampton. Peter, I mentioned, was waiting to go to Cambridge, and he did go to Cambridge and read maths. And I'm not sure the combination of good fortune or bad fortune found himself back teaching at Wolverhampton College, Wolverhampton Staffordshire College, and actually using the machine again in lessons. That's Peter Burton. Next to him is Bart Fossey, the senior mathematician from Harwell, the chap that had actually set the race against the machine. Me in the middle, Dick Barnes and Ted Cookie-Arbor. Ted Cookie-Arbor at the time was becoming increasingly frail. His family bought him a lung for the day. His son said to me, Ted would have crawled over hot coals to get to the museum that day to see the museum working. Sadly, he passed away not long afterwards, but this was literally a fantastic day. It's worth having a look at YouTube for the video of the machine. If you search for Harwell reboot, you'll find that. One of those peculiar videos that suddenly goes viral with over 1,000 hits just over that weekend. Quite incredible. Bart Fossey was very kind and actually agreed to redo the race. So Bart Fossey sat down with a calculator, a Brunsviga, and actually sort of ran the race against the machine as well, which I think is incredibly good sport of him. The machine itself now, a slightly better picture, is used absolutely every day. Oh, hang on, we're in COVID, aren't we? Before this, was used absolutely every single day. School parties visit the museum pretty well every day, and hopefully we will restart shortly. It is a perfect perfect machine for demonstrating computers. It's slow, so you're actually able to see what's going on. And the fact that the Dekatron tubes show the exact value in each of them, it means that we can actually go up to the machine and point out and say, yeah, we can see that this store contains 1 and this store contains 2. So we'll program an operation, an addition instruction, put the value in there, and actually follow the steps perfectly. And that's been really about school children. School children like to see things working. They also like the hint of a slight hint of danger as well. So this machine is humming. It's 1.5 tons. It's about 12 feet from side to side and about 8 feet tall. So there's a certain amount of excitement and danger with the machines running. But it runs absolutely perfectly. We can single step through the code. We have students that actually have prepared, we send out a pack of information to students beforehand with the order code and some sample programs. And we've had students arrive that punch their program actually while they're at the museum, and we run the code on the computer. In terms of maintenance, actually, I think Dekatron tubes be pretty well foolproof. Relays, again, as long as you have some handy ex-Strouger engineers that can actually trim and line up all the contacts on relays, they're very reliable. Some of the components, some of the resistors and things have actually changed value, capacitors as well, which puts them slightly out of the spec for what they're required in the machine. So again, typically the original capacitor or resistor was left in place, and there's a substitute doing the job alongside. Same with the power supply. The power supply looks absolutely identical, but some of the there are a lot of extra additional facilities in the power supply to monitor exactly what's going on. We don't rely on a fuse going or somebody noticing the smoke running in the back. There's a whole variety of Arduinos and sensors around the back of the machine, checking that everything is actually behaving itself and is still happy. I've sort of accelerated through this fairly quickly. There's a couple of slides I did want to show you. First of all, though, have a quick look at Harwell Dekatron. There's a lot of information on YouTube about the machine. Harwell Dekatron for the volume 1 million hits as well. That is really quite a special video. It's worth seeing that. What I did want to show you, and I've taken it out of the slides, you're going to have to forgive me. I'm just going to go and find this particular slide that I would like to show you. And it's these. I'm going to unhide that one, and show that one. These are the paper tape readers. That could be, and it looks a tad short, a subroutine. There are 7 paper tape readers in the machine. So typically what you do is have the control program on one paper tape reader and then calling out to different paper tape readers to do a subroutine. So let's imagine this loop of tape did a, it's not long enough for a square root, but let's imagine it did a square root. You could actually put the value you're expected to calculate in the accumulator, and then under program control, switch out to this tape reader, which would then actually read in that program from the loop of paper tape, perform the operation to do the square root, and then transfer control back to the other paper tape reader with the control program on. Now, these are the electromechanical tape readers I talked about, which would actually wear through that tape fairly quickly. But you can imagine with a little bit of thought, and if I go back to the sort of typical program for some of the programmers in the audience, with 7 tape readers, one reader declared as the control program, and then up to sort of 6 subroutines that you could build in. This is really quite a sophisticated machine. And usually it has hardware multiply and divide built in. But for its time, I think it was really quite an incredible design actually as well. Easy to program, easy to fault find, and with a single step facility, stepping through code. So one press of the button would read one instruction from the paper tape. We can actually follow the machine working. It's a beautiful machine to actually demonstrate and to show people using the machine, using the computer and programming the computer. Now, I'm conscious of the fact I've rushed through. I was given 45 minutes, and that's exactly 45 minutes, that machine. But I think we've got quite a few people in the audience as well that actually can add to the story. John, right.
Okay, Kevin, absolutely brilliant. I was totally oblivious to the time. A wonderful talk. If anyone's got questions, please do one of 2 things. Either use the raise hand function and I will turn you on as quickly as I can do, or if you don't want to speak, please basically use the chat function and I will get to you as quickly as I can do. Right. Okay. Mike Ted has got a question. I'm just going to allow you to talk, and I'm going to promote you to panelist Mike. See.
Yeah.
Ted, Mike, the floor's yours.
You can see. Can you see me? Yeah, I can't.
You're just coming in now.
Oh, we can hear you.
Yeah, we can hear you. That's the important thing.
Yeah. This famous program done for Chubbs, I can add a little bit with that.
Oh, right.
The program was actually written by Peter Burton and myself, the 2 of us. We were both on our way to Cambridge, and the school wanted to keep us on the books until the day when they got their money for how many students they had. Something's wrong here. Yeah. So we spent quite a bit of time because we'd finished school, but were still at school, up at Wolverhampton working on this program. Yeah. And it was a tremendous pleasure for me one day when I moved to Aberystwyth as a lecturer in 1972. And when I got there, I was given a key to the front of the building where my office was. And it was a key to the lock that we had designed for Chubbs. It was a great pleasure to have done a really useful program on this computer.
Yeah, I think it was it Commonwealth Week as well, I think, wasn't it?
Again.
I think it was Commonwealth Week as well, I think, wasn't it, really? The college wanted to actually get lots of publicity.
Well, yeah. I mean, there was an article in the local Express and Star, and starting off saying that you wouldn't expect schoolboys to be able to program a computer, and of course, my 6-year-old grandson does these days. But Kevin mentioned the facility it had of single step, and that together with one's ability to read the stores, you became very expert at that after a while. This meant that you could debug programs very easily, thanks to these facilities. Another thing I would say, it's mentioned about the paper tapes wearing out. It was my introduction to algorithm analysis, because you had to work out roughly how many times a particular piece of code would be used. And that then gave you the guide as to how many copies you had to have on the loop, which incidentally went round nails on the wall and all sorts of things. The very central loops we did use Mylar for, but we didn't have much Mylar. It was expensive, as you mentioned.
That is fantastic, Mike. I thank you very much for taking part. So I take it that you didn't go back to Wolverhampton after Cambridge.
No, I became a mathematician until eventually I decided that maybe I should go back to computing, and worked in industry, and then went to Aberystwyth, where I stayed for the rest of my working career.
Thank you.
Susan, I promised I'd let you come in at this point. Do you
Yes, thank you.
Premonitions you'd like to add into it?
Well, yes, there's several things. I was just a schoolgirl in 1964-65 when I went to night school at Wolverhampton Tech, as it was then.
Yeah.
And did my course on the Which computer. Would that be Fortran 4, I think? And I just thought it was absolutely amazing. And I often give lectures about how I programmed this computer, and I would spend hours putting in, was it Fortran 4?
Well, I think it was Fortran on their ICL machine, but yeah.
Whatever, a simple equation, and then I would get the result out there. It was absolutely amazing. I have to say, I'm quite disappointed that these days it seems to still be mainly the boys who are doing the programming, and I think us girls are just as good. But yes, but I programmed the Which computer in 1964, 1965, and it was absolutely wonderful. I went up there for night school every week, and at the end, did a Fortran program, X plus Y equals Z, and when the result came out, you thought it was wonderful.
I think the machine was it's not an exaggeration to say the machine was loved. I think people have told me that at night you could actually see the machine through the windows of the college up in its lab, and people were fascinated by it from that point of view. So that's quite wonderful. Thank you, Suzanne.
Okay, good.
We've had 2 questions in on chat. Jonathan, I'll unmute you if you like. It's asking about the accuracy of the machine. Obviously, you've got you're both doing integer and floating point arithmetic on this. What was the accuracy of it?
Right. It's fixed point. So all numbers are. I'm just trying to actually find. Numbers are. Hang on a minute. The other trick is write a book. Write a book, because then you can forget everything and then go and look at the book again. 1 second. 1, 2, 3, 4, 5, 6. It's fixed decimal point, so the numbers it could store are from minus 9 point. 1, 2, 3, 4, 5, 6, 7 decimal points. So minus 9.97s up to plus 9.97. So yes, and then programmed in decimal as well.
Okay, Jonathan, I'll turn you in. I'll put you on where I can find you again on the list, so you can come back on that one. We have another question as well in, and I'm going to get this name wrong. Sahul Rana. You mentioned that the Guinness Book of Records in 1973. Could you elaborate on this?
Didn't come back to that. Yes, Cecil Ramsbottom, who promoted the machine so well, obviously had it listed. When the machine was restored and we held the reboot event, I went back to the Guinness Book of Records. That's a very different operation these days from what it was. But eventually we managed to track the right people down and actually had the machine re-evaluated as still the world's most durable computer. And in 1990, let me just find the date, 1990. I'll find it. They actually issued another certificate for it. So it's actually on the wall next to the computer. Still the world's oldest working digital computer.
Okay. Dan, you wanted to come in. You've got your hand up for a question. Do you want to? You should be able to speak.
Yeah, hopefully people can hear me. I was just going to enlarge a bit on the New Commons Society's involvement in this, of course, because Mike Constable, who worked at the Collections Centre, was actually chairman of the Midlands region of the New Commons Society,
Yeah.
and is still an active member of the society. And of course, between me and him and Kevin, how do I put this? I think, managed to persuade Birmingham that they should let the machine go and be restored.
Well, and in fact, actually, we've since been back to Birmingham because there's another machine that they had in storage called the HEC 1, which is a machine that BTM produced, and they were happy. They said, yeah, absolutely, take it, put it on display, restore it, and so on. We had a visit back from the museum. They came down to see what we'd done with the HEC 1, and were extremely disappointed that we decided, in fact, it wasn't a candidate to be restored. Literally too much missing and too much damage as well. So there are several machines still in Birmingham which I'd like to get their hands on. That huge Ferranti Orion machine would be a candidate. Space.
Does anybody else wish to come in at this point?
Looking at the chats.
I'm looking for the chat here. What is the operating voltage of this? Is it a full mains voltage or higher than mains, or is it can't be a reduced voltage?
Well, all the relay controls are, in fact, if I find a picture, you will. Hang on, find a good picture of it. Let's get rid of that. No, let's keep going, Karen. 1 second. There. All the relays are all 50 volts DC. They're all post-uppy style relays. So there's a 50 volt DC power supply for the whole thing. And then the mains voltage on the Dekatrons, and I'm not an engineer, so I'm just checking with my colleagues. It's around the 120 volts.
Okay. So so basically it's a relatively low voltage. I was hoping.
Yeah, I mean the whole thing's only 1.5 kilowatts. The whole thing, including all the paper tape readers and the printers.
Yeah. So yeah, I was actually we had somebody who said they were coming to the talk who actually worked on the actual manufacturing and testing side of the Dekatron tubes when he was younger, and I can't see him in the audience. So John, if you're there, if you wanted to contribute, please do come in at this point. Andrew as well, you've just put your hand up. Do you want to ask your question, please?
Yeah, yes, Kevin. I was somebody else who used to haunt the Birmingham Museum, in my case, from 58 to 64, which was before this. Behind the Fox and Geese machine, there was a large demonstration panel which had lots of Dekatron tubes in it.
That was this.
Do you know anything about that, please?
Yeah, that was part of this machine. I remember the Fox and Goose machine, and the Harwell machine was up. Not all of it was upstairs. This was upstairs behind the big Magnox cutaway. I think that was there. There was another couple of machines there as well, weren't there? But part of it was actually there as well. Birmingham Museums, I mean, don't let me get started on the think tank. But Birmingham Museum Collection Centre.
Please don't start on think tank. We have good relationships with think tank. We want to keep them that way.
the old, it was fantastic. Everywhere you turned was another, I mean, just silly things like there's one room with just a collection of musical boxes and which is amazing, fantastic space. And I believe I don't live in Birmingham anymore, that the building is still there and still empty.
Okay, thank you.
Thank you.
Conscious of time, Kevin, that was absolutely wonderful. All we now need to do is organise a day trip to come along and see you all.
Yes.
and all have a play with this machine.
Yeah.
All I can say on behalf of everyone is thank you. It's wonderful that machines like this have survived, and that more than that they've survived, and that the effort has been made to keep them going, because it is only through simplifying modern technology so that people can see it in this way that you can actually, it is much easier to sell what is going on and explain what is going on in a modern machine with something like this than it ever is on any other method at all. And so from an educational engagement point of view, and seeing a pile of flashing lights like that is nothing better than engaging a pile of school kids and everything else like this into there. It's absolutely wonderful. Everyone, all I would ask you to do is, could we please thank Kevin in our usual way, and basically thank you all very much for coming, and I hope to see as many of you again as possible on the 16th of March.
Thank you all, chaps. Ladies and gentlemen, cheerio.